Topic 6.2. We'll be solving systems, nonlinear systems. And this nonlinear system is a system of 3 variables. So we're going to choose a single variable to eliminate from all of them. And let's see, I want to choose the y's because we have a negative y here and a positive y there, and they'll cancel out. I'll come back and I'll cancel out the negative 3y next, but I can cancel these out immediately. So these come together and we get 6x, the y's cancel, and we get negative z. And the negative 4 and the 12 become 8. Now, to get rid of the negative 3y, we're going to need a positive 3y. So I'm going to multiply this term right here by 3, giving us 15x plus 3y minus 6z and 36. So now we're able to combine these two to eliminate the y's, and I end up with 17x, y's eliminate, and negative 2z, and the negative 15 and the 36 get together, we get positive 21. And so now we're down to x's and z's alone. Okay, now from here I want to cancel out my z's. I have a negative 2z, so I want a positive 2z here. So I'm going to multiply this by a negative 2. Multiplying by negative 2 gives me a negative 12x, a positive 2z, and a negative 16. So now I can combine these and eliminate the z's. So a negative 12x and a positive 17x gives me 5x. These cancel, and a negative 16 and a positive 21 gives me 5. And 5x equals 5 implies x is 1. So I've just solved for x. Now let's back up and now replace one of the x's with 1. Let's replace this x right here. So we have negative 12 times 1 plus 2z equals negative 16. This gives us negative 12 plus 2z is negative 16. And when we add 12 to both sides, we end up with 2z equals negative 14. Negative 4, should I say. Well, 2z equals negative 4 implies that z is negative 2. So now we solve for x and z. Now we're going to back up to the original, and now we can replace the z's and the x's. So let's go back to the original here, this is number 1, and we have x is 1, negative y, and z is negative 2 equals negative 4. The 1 and the negative 2 can combine for a negative 1. Sorry, the 1 and negative 2 combine for negative 1. And then when I add 1 to both sides, I get negative y equals negative 3. Negative y equals negative 3 implies y is positive 3. So the solution of this system would be x is 1, y is 3, and z is negative 2. Next, number 4. Number 4, we have a system here of 3 variables, and I want to cancel out one of these. So let's say if I cancel out my y's, so let's say I cancel out this y and this y, I need to change this to a negative y. So let's multiply this by a negative 1, which will give me a negative y, a negative z, and a positive 6. So that when I combine these, right here, the y's will cancel, and we'll get x minus z. The 3 and the 6 become a 9. Okay. Now, this does not contain a y to get rid of, so the y is already gone. So this is usable right now. I can simply move this over since it does not contain a y. So now I have x's and z's. From here, I can combine these and the z's will eliminate. And I'll end up with 2x equals 10, which implies x is 5. Well, if x is 5, and I know that x plus z equals 1, I can use substitution, make this 5 plus z equals 1, and this implies z is negative 4. From here, I can back up to the original problem here, and to find out what y is, I see that x plus y equals 3. I can replace x with a 1 plus y equals 3, and this implies y is 2. So the solution of the system will be x is 5, y is 2, and z is negative 4. Next, we have a nonlinear system of two variables. Let's see, I want to use substitution. And here it says if I have an xy, I can replace that with 8. I have no xy's here, so what I'm going to do is I'm going to multiply this by x. And we'll get 3x squared plus 2xy, there's my xy right there, equals negative 16x. And now that I have an xy, it can be substituted for 8. So 3x squared plus 2 times 8 equals negative 16x. 2 times 8 makes 16. Since this is a quadratic, I want to move everything to one side and set it equal to 0. So 3x squared plus 16x plus 16 equals 0. Okay, now I want to solve for x. I'm going to try factoring. And this will be 3x times x. And for the 16, let's try 4 times 4. Inside we'll get 4x, outside we'll get 12x, and the signs have to be the same. And this would make our 16x. So both signs are positive. So this implies 3x plus 4 can be set equal to 0, and x plus 4 can be set equal to 0. 3x will be equal to negative 4, and this implies x equals negative 4/3. Here, x equals negative 4. Now we have two solutions, which means that we have two replacements for x. If x is negative 4/3, I can replace it here and have negative 4/3 y equals 8. Then I will multiply both sides by a negative 3/4, which will give me y. 8 divided by 4 is 2. 2 times 3 is 6. And a negative gives us negative 6. So the point here would be x is negative 4/3, y is negative 6. Now, x being negative 4, if I replace it, gives me negative 4y equals 8. Then divide both sides by negative 4. This implies y equals negative 2. So my second solution will be x is negative 4, y is negative 2.